Tim Collins and by Mike Humphrey, who will be presenting for you this evening. We have a lot of stuff to go through and a lot of stuff to look at. Before I get started, though, I would also like to thank you for joining us. I'll be checking in and looking at our chat. So if you have some live chat, it looks like Tony Labruto says he's not hearing sound. So we'll be checking into that. In a short second here, as our producer Gene is looking at it. So Gene says, Amy Langnorth is saying this is going to be amazing, and Tony Labruto said there was no sound, Gene, but I think there is, and so we'll be doing. Tony, you can respond if you're hearing us live, so you can see that we are doing this live for you. But also, folks, I want to thank you for joining us. And we are also reaching out to you to assist us in continuing these programs. We've had a lot of success in doing this. We've had a lot of people come and help us out and help us bring these live events to you. And we were looking for your support. Yes, you heard me right. We're looking for your support. Any little bit can help, but we've gotten high-speed internet out at the observatory. We got a big check mark there and looking forward to bringing some live events from that observatory. We are returning to live events at the observatory. We're actually to bring a few of them to you this summer, well, actually this fall, as we came into the end of the kind of COVID situation as we're looking at. So please just consider making a donation to help us and spread our love for astronomy through virtual star parties. We've got some initiatives of doing some observatory maintenance as well as bringing Wilson Star Search back to you. And let's see. Oh, Amy says the sound is fixed, and so says Tony. So thank you very much for helping us out there. And so, again, we really do appreciate you, and we love bringing this to you. We love spreading this love of astronomy to everybody. And so, without further ado, we're going to be getting into our presentation this evening. And our first presentation this evening is going to be brought to you by Emily Ann. Emily Ann is a board member in the Buffalo Astronomical Association, an outstanding visual observer. She really knows what she's talking about. And today, Emily Ann is going to present to you about the November 19th lunar eclipse. Take it away, Emily Ann.
Thank you very much, Dennis. Okay, so we're going to talk about the eclipse. Let me share my screen here. We'll get started with that. Okay, so hopefully you can see my screen. So we'll just jump right into it. So if you're watching this, you probably know what an eclipse actually is. You may also know the difference between a lunar and solar eclipse. But what's interesting about this eclipse is, first things first, it takes place on November 19th, taking place between 1 a.m. and just about 5 and 6 a.m. is when it's going to end. But the interesting thing about it is this is a partial eclipse. So I wanted to go over the basics. What makes it a partial eclipse as opposed to what's called a total eclipse, a total lunar eclipse? And eclipses, as we all know, they only happen when the moon and the sun and the earth are all lined up in the right position. And as you can see, we've got our lovely diagram here. Here's the sun and the moon is in the back, and it's casting light on the earth and back behind it. So the eclipse, a lunar eclipse, happens when the moon passes through the shadow cast by the earth. And eclipses actually tend to only happen 2 times a year, what's called eclipse season, which is a cute name for it. I actually did not know about that. And why is this the case? This is because of the intersection of orbital planes. So I'm going to get right into it here. If you think about yourself, if you had like a hula hoop around you, right? Okay. So you're the Earth, and the hula hoop represents the lunar orbit, okay? So the way the moon is placed when it rotates around the Earth, it doesn't quite sit exactly straight. It kind of, if you tilted that hula hoop in front of you maybe, so it was kind of off axis, right? So that's kind of the way I believe it's maybe like 5% is off its axis, so it's not exactly straight. It's not a straight plane. And so the Earth also rotates around the sun like this, where it's not exactly a completely flat plane, it's tilted a little bit. So if you had 2 hula hoops, right, okay, and they were intersecting, that is kind of when that intersection happens, is when you get the chance to have an eclipse. So because of this variation, because of where the moon sits when it goes around the axis, if you look at the second diagram here, you'll see that sometimes the moon, does not pass behind Earth's shadow completely. And sometimes it only passes partially. If we look at this pink moon up here, you'll see that it's passing through this penumbra, this shadow that the Earth is casting, but it's not quite in that umbra section, which is when there's full shadow cast. A penumbra is only partial shadow. So anyway, we'll see in a sec how this actually looks, and during this lunar eclipse and the difference between a partial and a total. But that's kind of the basics, and that's why this is a partial eclipse, is because in this case, on the one on the 19th, we are passing partially into that umbral shadow, but not completely. So when the moon does not fully enter Earth's full umbra, that full shadow, when it doesn't do that, you get the partial eclipse. And another thing that's interesting is the size of the moon based on, when the moon is rotating around the Earth like this, the size of it, when you observe it, the size changes from where you're observing. And that also does affect solar eclipses. That affects what's called an annular solar eclipse versus a total solar eclipse. So that's another phrase you might hear sometimes where you say, what's an annular? Why is that different? It is actually just because the moon, as observed from Earth, is a little bit too small to completely cover the sun. So you do get that ring effect, but you don't cover the full sun there. So it's still amazing, it's an amazing thing to observe here, but it's just interesting that that's because of the size of the moon as observed from Earth. When you're looking at it, it looks smaller, so it doesn't cover the full sun. So it doesn't cover that full disk, but that's kind of our basics here. And I'm gonna go back to this, when I go forward, I might go back just to show again the difference between that partial and total. So the eclipse timeline. So like I said earlier, it starts just around 1 a.m. on November 19th, which is next Friday. And I will actually be popping between this and Stellarium, which is a observatory program, to show you a simulated view of what that'll look like. So at 1 a.m., just about, the moon starts entering Earth's penumbra, which again is this partial shadow, not the full shadow cast by the Earth, but a partial one. So it's going to start getting darker. And then just around 2:15 a.m., the partial eclipse begins. And this is when the moon starts entering our umbra, which again is our full shadow cast. And then at 4:02 a.m., that is the maximum eclipse. So the moon is about 97.9 apparently in that umbra. So that is very, very close to a total eclipse. This is a pretty good, if this is maybe your first eclipse ever, your first lunar eclipse that you want to view, it's a pretty good one. You will not get a period of totality, which is what's called when, you're in that full shadow for a period of time. We're not going to be getting that, unfortunately, but this is the max point, so to speak. And then after that point, the moon is going to leave the umbra and pass back into the penumbra. So at 5:45 or so a.m., the moon partial eclipse is ending. And this is actually where the moon is going to be very low on the horizon, unfortunately. Lunar eclipses can take place any period of time throughout the night. Unfortunately, as it so happens, based on our time and all sorts of factors, it's going to get kind of low. Some lunar eclipses, unfortunately, you can't even fully observe because at that point the moon has already, passed the horizon. It's a little bit too low. And at 7:03 a.m., the eclipse is completely over. The moon is not in any of Earth's shadows anymore, so it's time to go to bed. And I'm actually going to pop over to Stellarium, and let's see, hopefully that showing on the screen, hopefully? Okay, excellent. So here is Stellarium. This is a simulated view of what the moon is going to look like. And this is about 12:30 a.m. So we're going to start here. Like I said, it's going to start at 1 a.m. So we're going to just speed up time a little bit here. Okay, so we're going to see. So it's about 1 a.m. now, and you're going to see it's going to start getting darker, right? Okay, we're going to pause for a moment right about here. So this is almost the maximum eclipse. This is about 3:45 a.m. And as you can see, the moon is reddening. This is a typical, if we were in a total lunar eclipse, it would be red like that. And then we're going to get, let's see, sped up a little bit here. But this is just about at the max point. So, and then we're going to keep going on past that. Okay, and then, but yeah, this is a simulated view. But let me go back to my slideshow here. So yeah, that's the whole eclipse timeline there. So again, it would look a lot different if you were observing this. And some tips, when you're observing, oops, Hold on. So some tips if you went out to observe this is that, unlike a solar eclipse, a lunar eclipse, luckily you do not need any crazy safety measures. When you're doing a solar eclipse, you definitely, I know that we do have some upcoming solar eclipses here, but where you would need to have safety measures with your eyes, but we're just looking at the moon here, so nothing to worry about. At this time of year, you definitely will need warm clothes, so that is kind of a safety measure. um you know and what you could do is, if you have the whole night to spend, perhaps, I don't know, in my case I probably won't be watching this the whole night. I might just go out at the max eclipse, but you can kind of go out a few minutes at a time when you're in each phase. Maybe go out at 1:30, 2:30, 4:02 a.m. Definitely want to catch that maximum eclipse. But you can kind of compare the color and the brightness, and take some observations, do that citizen science. And I actually will talk about the color and brightness in just a moment here. But yeah, go out, as the night goes on. And then you can observe a lunar eclipse with your own eyes. You can use a telescope or a pair of binoculars. Any astronomical equipment will work, but even with your bare eyes, you can still see the color change of the moon there, and you can see the effect of the brightness on it, which is pretty cool. I would maybe recommend lunar filters if you do have a telescope, or color filters, because the lunar eclipse is going to take place during the full moon here. It will be pretty bright, so it's not going to hurt your eyes, but sometimes it does help to at least cut down on the brightness, so you don't have like one eye that's incredibly blown out and then the other eye is normal. It's kind of annoying. And always, lunar imaging. We have some wonderful eclipse photos, some wonderful solar eclipse photos, but always a fun time to maybe bust out the camera or even take a photo. Maybe if you have just a phone holder, you can take a photo with your cell phone and that'll look great as well. So, and one other thing I wanted to talk about is, again, this is another thing I didn't know about until I started reading about this. It's called hopefully I'm pronouncing this right, the Danjon scale. And this is a subjective way. It's not really a scientific measurement, but it is a way that if you're observing a total or even a almost total lunar eclipse, you can determine the color and the brightness of the moon on the scale. So as you can see on the left side here, we have, this is a regular moon. And then there are these different numbers. What do the numbers mean? Well, as the values increase, this kind of shows you the different ways a moon can look. And what I want to go into here is, why does the moon look red? Why does it look like this? What is the difference with this variation of color and brightness? Well, that is actually because let me go back here, go back to where. So when the moon is back here, when the moon is in Earth's shadow like this, you would think, why do we even see the moon at all? Because it's in the shadow. It doesn't make sense. Well, the sun is still casting light, obviously, on the Earth, and the light is actually being refracted off of Earth's atmosphere, okay? And when the light goes through, the blue waves of light are actually, they're kind of scattered. They don't go through, but the red does make it through. And this is why, we still see some red light on the moon. And the variance in light actually depends on different properties of Earth's atmosphere. So for example, it's very common to note that if you are viewing a total lunar eclipse from somewhere where like a volcano has recently erupted and you have the dust in the atmosphere, that would actually make the eclipse darker because of the particles of dust in the atmosphere, or maybe water in the atmosphere, water vapor, clouds, and that actually affects the color that you see of the moon. So people in different locations, everyone on the night side of the Earth can see a lunar eclipse when it happens, but if you're in a different location and maybe the atmosphere is a little different where you are, you're actually going to see the moon a little bit differently. So I thought that was really neat. And you might notice here that I wrote total lunar eclipse. Well, in this case, because we're so close to a total lunar eclipse this time on the 19th, you will not, as we saw maybe when I showed it in Stellarium, hopefully you might have, I think there was something with it, so you may not have gotten to see, unfortunately, but I'll show in a moment what it will look like in image form, but you might still be able to get a number. You're still going to get some variance because we're very, very close to the total lunar eclipse. So I thought that was pretty neat. Again, this is something I didn't know about. So hopefully, if you get a chance to go out next Friday at 4 a.m., see if you can maybe attach a number to what you observe the moon. Again, it's not going to look completely like this. It may not be as vibrant as these higher values here, but it still will be pretty cool. And it's good practice for the lunar eclipses we will be having next year. So I would say get out there and still try to assign a number to it. Try to assign your Danjon number. So I did want to show these are another simulated image of what the lunar eclipse next week will look like. On the left-hand side, we have maybe a typical view through a telescope, so it's pretty, zoomed in, pretty close. And you can see, hopefully, on the right-hand side here, just a tiny sliver where, again, this is all simulated. This is not what it's actually going to look like, but you can see that it's almost there. It's really, really close. And then on the right-hand side, we have a flipped binocular view. And this is not, it's kind of to scale. It's, I had to cut some off, obviously in binoculars, it would be much, much smaller. But again, you can see this telescope binoculars or even just your own eyes. It's still going to be pretty cool. And then, yep, I generated this. So this is at 4:02 a.m. So this is the maximum eclipse time. And then I did want to talk about upcoming lunar eclipses. So we actually have 2 total lunar eclipses coming up in 2022. So if you miss this one and it's 4 a.m. and you don't want to go out and it's really cold, I totally understand. Because myself, I'm definitely going to look at this first one on the left-hand side. Again, this is a simulated view, but this is a total lunar eclipse that will be occurring on May 15th to the 16th. So, in the spring, hopefully it'll be a little bit warmer. And another very cool thing about this eclipse is that the maximum eclipse time is going to take place at 12 midnight. So it's, a nice time in the middle of the night. You view it, you go back to bed. I like that. And then the second eclipse is going to take place almost a year from now on November 7th to the 8th. One unfortunate fact about this one is that the max eclipse time is actually right around like 6 a.m. So that's our max time. Unfortunately, it's going to be very, very low on the horizon here. It's got an altitude of 10, which is very low. So unfortunately, I think this one, you might want to go out and you could see maybe the moon darkening before it kind of takes on that reddish color. You might be able to get that, but unfortunately, depending on where you live and your horizon at home, it might not be a good one. So I would say hold out for the May one if you can. I think that one's going to be really fun. And one other cool thing I found out about these eclipses is they're what's known as a central eclipse. So if we actually go back to I like this diagram a lot. So a central eclipse is where not only is the moon, in this umbra, in this shadow, but it's very close to the center of Earth's shadow. So it's a good looking eclipse, hopefully, right? If we actually can see it, if we don't get clouds and stuff, but it's this orange moon right in the center. It's passing very close to the center, the direct center of that shadow. So that's why it's called a central eclipse. And these are a little bit more rare, actually. So again, both of these eclipses next year are going to be this type of eclipse. And I don't know, I think I've definitely seen a few lunar eclipses, but I think I definitely want to take a look at the one next week, because it's going to be so close to a total eclipse. But I think the May one is going to be very cool. I'm sure we're going to have BAM members talking about it, imaging it, having all sorts of fun with that. So I would say, next week, though, next Friday, definitely get out if you can at 4 a.m. and, take a peek. It's always a good time. I know that they'll probably have streams as well. Usually the time and date site does a stream. So you can always catch that later if you don't miss that. If you can't see it at the time, you can always come back and watch it. But that's about all I got. Keep looking up and get ready for 2024. That's what I'm going to say, because we're going to get the big famous solar eclipse. It's going to come right through. And this is, solar, not lunar. So this is going to be the ring of fire, the big one, so that keep your eyes peeled for that one. But until then, maybe enjoy some lunar eclipses. And that's all I got for now. So back to you, Dennis.
Outstanding, Emily Ann. Outstanding. That was a tremendous presentation.
Oh, thank you.
Tony really said that was very good to know. A lot of great stuff coming out. And Don says hi, and that's really cool. And we say hi to Amy Lang and to Karen. And to Tony Labruto again. Again, thank you so much for joining us. And Emily Ann, that was just an outstanding presentation. Now, if anyone out there in our Facebook Live audience or on YouTube Live, yes, we are also on YouTube Live. If you have any questions, please go ahead and send them to us, and we'll try to do our best to answer those questions right away for you live. And since Emily Ann was able to show a little bit in stellarium, back in 2015, there was a total lunar eclipse, and we were able to see it out at the Beaver Meadow Observatory. And so what I did is I had some imaging that was taken there. And so this is the imaging of the total lunar eclipse in 2015 out at Beaver Meadow. And the images aren't all stacked up, but what you're going to see is the eclipse happening. And I've kind of shortened the time here for you just a little bit. but this is what a total lunar eclipse would look like. And you can see all of the stuff that Emily Ann was just talking about. And so, yes, you could image even this partial lunar eclipse on November 19th. And what you'll notice here is that you can see these things right here in the background. I think those are called stars. That's kind of interesting as well, that you can see it when that eclipse reaches totality. It's pretty interesting to see. There's also some neat stuff that you can do as you're watching this total or even partial lunar eclipse. And so what I'm going to do is I'm going to go ahead and stop this so we won't ruin the whole thing for you. But Dan Marcus, our observatory director, had a question for Emily Ann, actually more of a comment than anything else about those stars we just saw in that lunar eclipse video I showed you. So Dan, how about you tell us a little bit about those?
Yeah. Well, one of the fun things I always found about total lunar eclipses is the fact you can actually see the fainter stars being occulted by the moon. Normally you have to wait till the moon's a thin crescent, where you can actually see these stars being occulted by the moon. But during a total eclipse, it's just a real blast. You can see the faint stars, you see the big moon. You can actually watch the moon travel amongst the stars. It's one of the few times you can really pay attention to it. It's a lot of fun to watch, a lot of fun to image as well.
Yeah, I looked that up actually in Stellarium. So, hopefully it's accurate, but I think we get a couple eighth magnitude stars that it's going to occult. So just around that area of maximum eclipseness. So yeah, it seems like might get to, I'll definitely keep an eye out for that because that sounds really neat.
Yeah.
So very
Yeah,
cool.
it actually works best if you look at it with a telescope or binoculars.
Right.
If you're looking
Yeah.
for star occultations, it's the best thing to use. Naked eye is not the best way to go, but it's a real hoot to watch that.
Yeah.
And for those of you who don't think it's a real hoot to look at, I will have to tell you from firsthand experience, I didn't think an occultation would have been that impressive, but I was able to be out at the Beaver Meadow Observatory and looking at our 20-inch obsession telescope. Yes, we have one of the largest telescopes in Western New York to look at and to look through. As Dan was imaging this occultation, I got to watch it. And let me tell you, it was absolutely stunning. I'm telling you, stunning from firsthand experience. So if you have the opportunity, if you have a telescope and are able to, you're going to want to watch this partial lunar eclipse on November 19th and even look for those occultations. And if you have questions, you can always ask us at the Buffalo Astronomical Association. You can join us on our website. You can ask questions there and we'll do our best to get back to you as soon as we can. Obviously, we're all volunteers doing this and we always appreciate spreading the love of astronomy, but definitely we love doing this. Now, Emily Ann, I have to tell you that Rosemary said this was a great presentation, and Tony says thank you, and so does Amy. Says this is Amy Lang says this is so cool. Mary also, Mary Wayand also said thank you, Emily Ann, very informative. And Michael also says what a great presentation. So again, Emily Ann, an outstanding job doing that presentation. Again, thank you, ladies and gentlemen, out in our live audience. Yes, we are doing this, a live looking up virtual star party. We don't have a lot of clear skies this evening, but we do have some really cool things happening for you. And so I don't have any specific questions, but next up on our presentation is going to be Dan Marcus. Dan is going to be telling us about the brightest comet of 2021 in the early morning sky. Yes, you heard me. The brightest comet in 2021 in the morning sky, Comet Leonard 2021 A1. Dan Marcus, take it away.
I can get this thing out of the way here. Yeah. Okay. One thing I always enjoy is a good comet. Comets are always entertaining because you never know exactly what they're going to do. Comet Leonard, was the first comet actually discovered in 21. That's why it's labeled A1. And it will be in our morning sky right now. It's currently there. It was discovered by Greg Leonard. He discovered it January 3rd. It's got a 80,000 year orbit and it's in retrograde, which means it got captured by our sun. And turns out, when I understand, this particular pass around the sun, it'll be ejected from the solar system, so it's not coming back. It'll be closest approaches to Earth on December 12th, and it'll be closest to the sun on January 3rd. These two dates are important. December 12th, when it's closest to the Earth, is when it's going to be the biggest and pretty much the brightest for us, maybe, at least for the northern hemisphere. The closest approach to the sun on January 3rd has the unfortunate event, unless you happen to be traveling south of the equator, that if you're in Australia, it'll be a wonderful event. If you're in Buffalo, it won't be so good. We'll get into that and show you where it is in the sky. And it'll be best viewed in the northern hemisphere until December 12th, which when it swings around to the other side of the sun for us, then hangs low in the western sky. So again, it'll be best viewed in the southern hemisphere after December 12th. When it gets to January 3rd and it passes close by to the sun, the tails, that's when it'll be at maximum, and it should be a pretty spectacular sight from the southern hemisphere. Northern hemisphere, we'll see. You never ever know. It's really what to expect. If you listen to the hype, and people will always tell you, my generation, it was Comet Leonard, and they discovered that one way far out, and we waited for Comet Leonard, and we waited, and they had fantastic predictions for this thing. And of course, when Comet Leonard showed up, we all looked at it and yawned and went back to bed. This thing should be Mag 5 or brighter. They're actually anticipating Mag 4 currently. If it's currently generating a dust tail, and it's this dust tail and the orientation between the dust tail and the sun that causes backscatter and will actually amplify the amount of light being reflected by the comet. So it may prove to be brighter, much brighter than Mag 5, which is just barely visible to the naked eye if you're out in the country. And they say, what is it that makes naked eye brightness? Well, astronomers, we call something that's barely naked eye pretty dim. The lay person, it's like really, really, really faint, very hard to see unless someone points it out to you. So you're expecting this big, huge comet like we had Hale-Bopp way back in the 90s. It's not going to be anything like that. This is going to be pretty decently bright. You should be able to see if you have dark skies, if you travel like the Java Center, if you're on Route 77, or you're up at the top of one of the hills looking down over the countryside, so you have a very, very low horizon. It should be naked eye from there. In the city of Buffalo, you probably won't see it. You may be able to catch it with binoculars without too much trouble if you know where to look. And let's see, best time, December 4th, the moon gets out of the sky. So December 4th through the 12th, in the morning sky, the moon won't be interfering with us. It'll be the best time to go view it. No moon means that you have darker skies if you're in a dark sky location, and that's where you're going to need to view this. All comets are best viewed from a dark sky location. If you're going to do this from the city, you're going to be very disappointed. This is going to require getting up at 4 o'clock in the morning and driving into some, or however long it takes to get to your, at least at a dark sky location at like 5 o'clock in the morning to really enjoy it. So you're going to need to do it before sunrise, at least an hour before sunrise. And we'll talk about that in a little bit. Binoculars, preferably on a tripod, will definitely aid in the search. A compass is a big help. If you know what the compass bearing is of the comet, and you can find that out from one of your planetarium programs, they'll give you the alt-azimuth coordinates of it. The azimuth coordinates are your compass bearing. You just line your compass up. Once you have the compass lined up, you point your binoculars with the compass, and once you know what the elevation is, you program in the angle of the elevation in your binoculars, and you should be able to see the comet as a fuzzy, indistinct star until you really pay attention to it. Once you see it and you get it locked in binoculars, you should be able to make out a tail on it. So, thing to do is stay tuned to spaceweather.com or heavensabove.com for updates and charts. They will very definitely be publishing images of the comet on those sites, especially space weather. And really important thing to consider is comets are fickle creatures. Some days they perform, some days they don't. You never really ever know with a comet. If the comet comes in and it doesn't happen very often like this one does, it may have a lot of pent up dust and gas that it wants to vaporize. It may break up as it passes around close to the sun due to gravitational forces from the sun. If it breaks up or spews out a lot of material, you get a really nice tail. The bigger the tail, the brighter the comet. Or nothing may happen. It may just give up and quit producing stuff, and which case you get a dud. This is what it looked like on November 7th. I was out at the Beaver Meadow Observatory. This is taken with a 200mm lens, a regular camera lens. I did have it on tracking, and those were 30-second exposures. So it's not like it's a real long exposure. To do 30 seconds, you need a telescope mount to track with, otherwise the stars get trailed. Once things get brighter, you may be able to catch it with a 200mm lens. If you've got a 200mm f2.8, you may be able to catch it like 1 second exposure, so you just get slightly trailed stars and not need a telescope mount for it. And it actually looks pretty impressive. There's a quick looking at stellarium. This is an hour before sunrise, or approximately an hour before sunrise. And we have Comet Leonard. You can see my mouse, I assume that you can, right up here. And this is on the 2nd of December. You'll notice that the moon is in the sky, so it will be interfering because moonlight will wreck the night sky for us a little bit. It's a little thin crescent moon, so it shouldn't be too bad, but it'd be a good time to start watching the comet. And as the comet advances from day to day, you're gonna notice the comet starts moving lower and lower in this morning sky at the same time in the morning. Here it's passing by M3. On the 5th, on the 6th, this is bright star Arcturus. If you can find the Big Dipper and you follow the handle of the Big Dipper, you just follow that curve of the handle of the Big Dipper, it'll lead you right to the bright star Arcturus. Once you've got that located, you should find the comet off to the left of it. It's a good way to at least know the elevation of the comet, and if you know that it's almost not quite exactly due east, just another 5 degrees, and get the star in there, line up binoculars on a tripod, poke it right there, you'll see the comet sitting right there. This is a time once it's up this high, I've got it, the coordinates over here. Let's see here for the time. It's at 6 o'clock in the morning. If you were to get there like at 5 o'clock, it'll be a little closer to the horizon. I'll give you plenty of time to watch the comet and see how the tail's doing on it. And as we move along, you'll notice the comet for the same time at 6 o'clock in the morning keeps getting lower and lower and lower and closer to the sun until we get to the 11th. Now, once we hit the 11th, the comet's going to be about as bright as we're going to see it in the northern hemisphere easily. And again, as Emily Ann was pointing out, this is the 10-degree mark. And 10 degrees above the horizon is not very much. You need to be on the top of the hill, looking down over the valley. Because if you're going to try it from the city, 10 degrees, it's going to be obscured by the trees. So you need to be at a high point when you're going to be viewing the comet, when you're talking the 11th of December. But at this point in time, the comet should be pretty bright. It should be easily visible at 6 o'clock to the naked eye if you know where to look for it. Once you find it binoculars, you should be able to find it easily with your naked eye if you figured out where to really go looking for it. Notice on the 12th, this is an hour before sunrise. The comet's nucleus is just getting above the horizon. Now you have a problem when you have a comet this close to the horizon because you're looking through all that atmosphere. The more atmosphere you look through, the dimmer the comet gets. So you might see a tail sticking up and not be able to see the nucleus. That's always kind of fun. And here, since it's an hour before sunrise, you have a contest between the comet and the night sky. If the comet's bright enough, as it rises, the comet gets brighter because you're looking through less atmosphere. But then the atmosphere is also getting brighter because the sun's following up behind it. So you have kind of a contest. So you don't know exactly when the best time to view it. So it never hurts to be, this is 6 o'clock, I'd be out there at 5:30 watching and looking and watching for the comet to rise. And then between that and sunrise, you figure out when's the best time to see it. You really won't know till you're there. Now, December 12th. You got up in the morning to watch the comet. You had the fun thing to do is see if you can find the comet in the evening, because it should swing over to the evening sky on the 12th. Actually, you might be able to see it on the evening of the 11th. Moonlight will be interfering until about December 21st. You're going to find that twilight's going to be more of a problem than the moon. Again, better visible from the southern hemisphere. This is their time to shine to look at the comet down there. The farther south you view it, the better. Therefore, the key date will be January 3rd when it's closest to the sun. If you happen to be taking a winter vacation to Florida at that time of year, I know some of these snowbirds like to go down there, or if you get friends with snowbirds, they go down to Florida this time of year. Good opportunity for them to see the comet after we can't. So here we are in the evening sky. This is an hour after sunset. It is not totally dark yet. Notice the comet is not even 10 degrees above the horizon. It's going to be very, very difficult to see the comet on the 12th. You're going to have to know what you're doing. You probably need a pair of binoculars, even though if you were like in Australia, it might be a lot higher up. Now we come to the next night. Comet's right there. Notice it's moving towards the south. I'm going to keep moving along. It moves over here. And the tail still points up, and the tail is always pointing away from the sun. The sun is setting. Now, as it goes farther and farther south, notice the tail is cocked at an angle over here. And again, the tail is always pointing away from the sun, because that's what comet's tails do. The comet tail is generated by the solar wind impinging on the comet and pushing the material of the comet away from the sun. So the heavier particles kind of have some momentum to them. They kind of try to follow the comet, so it'll give you a kind of a curved tail at this point in time. And the lighter particles, like the ion particles, will get blown directly away from the sun. So at this point in time, the comet starts to move into its own tail. Here we go. It's going to, on the 17th, it starts to pass just under Venus. Also going here, there's Venus. The comet's going to be under Venus. Again, you're going to need to find a low horizon. Go out to Lake Shores of Lake Erie. Be a good place to do it. And look over towards Canada where the sun's setting, and you should be able to find the comet someplace like that. But again, you're going to be looking through a lot of atmosphere. It is not going to be optimal viewing conditions here. Hop on a plane, might be a little bit better, but not by much. And notice we keep moving along. There's the 20th, and the comet just keeps pulling off to the left till it's almost due south. Now, it's already made a change here. Notice that the 180 degrees is due south. So it's moved to the southern side. And as we look at here, it's on the 24th, Christmas Day, day after Christmas. And we get to the 30th. And at the 30th, it's still pretty low on the horizon. Notice it's only 5 degrees above the horizon an hour after sunset. But if you happen to be in Florida, there's Florida. Notice it's almost 20 degrees above the horizon in Florida. If you happen to go to the Florida Keys, it probably would be 20 degrees. And on the 30th of December, if you happen to be traveling to Sydney, Australia, you're going to find it's almost overhead. Wonderful place down there. They're going to have a beautiful view of this comet. And the tail now here on December 30th, between that and the 3rd, when it gets close approach to the sun, is going to be a really pretty tail. And it's going to be a nice curved tail. There'll probably be a nice blue ion tail, nice straight spike with a broad dust tail. We'll see what it looks like from then. You never know. Again, space weather, I'm sure we'll have images of the comet along with Sky and Telescope. Now, in case you're curious, we had Comet Neowise back in 2020, and it had a similar trajectory. Here's a sequence I happened to take. Dark skies in North Java. I was on Route 77 up close by Perry Road, looking down across the windmills, and I was just taking a little standard Canon with a 250 millimeter lens. Nothing special. It was a fun thing to do, and it gives you an idea what you really come up against. And what you come up against is when the comet's really low on the horizon, you can barely see it. I mean, you can barely make out the stars because I obviously didn't have a whole lot of exposure on this thing. But watch this comet. The exposure does not change, but the comet's position in the sky does, and the amount of atmosphere that we look through to see the comet changes. So as we move along, you'll notice the comet doesn't go straight up from the horizon. It follows the ecliptic, which means it's going to come off at an angle. And as we keep moving here, you'll notice the comet starts to become more and more visible. Again, that's not due to the fact that we're exposing it more. It's just due to the fact that we're seeing it through less atmosphere and less muck. And you'll notice it comes up, it gets brighter, 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 brighter. And this is where you need to start looking at least 2 hours before sunrise. It may be low on the horizon. You may not be able to see it yet. You may start to watch it and you want to follow it. And you just keep following it until it gets to the equilibrium where the comet's brightness and its elevation and the sun's position are such that the comet appears to be maximum bright to the night sky. Once it got up about this far, we could actually see it with the naked eye. And you can see the sky slowly brightening. So the comet will be visible for a little while, and this is kind of what it'll be looking like at night. Now the comet here is probably a good 20 degrees up in the air. It was pretty high. And remember, we said after the 12th, it was going to be hanging down between 5 degrees and 10 degrees if we're lucky. But that's what we'll see. You can see the airplanes flapping by. That's the end. So with that, I don't know if there's any questions. I'll be happy to answer. If I can, that is.
Well, Dan, that was an outstanding presentation. Certainly the brightest presentation of 2021 about comets. I don't have any questions on Facebook Live here. I don't have a view of the YouTube Live. If there's any questions there, I haven't seen any, but no questions there. So, but we certainly do enjoy those presentations, really outstanding. And obviously you can stay in touch with the Buffalo Astronomical Association. And so really, thank you so very much for that wonderful presentation about the brightest comet of 2021, Comet Leonard 2021 A1 in the morning sky. Yes, you two folks can see it. And we really thank you for joining us here on Facebook and on YouTube. And just another side comment, we do bring this to you, and we do bring this because we love sharing our love of astronomy with everyone out there, and we could use your help in doing so. So you can do a donation, and I'm going to post right now into the chat as my name, Dennis Bartkowiak. I'm posting a chat link in the live section of the Facebook Live, so that you can go ahead and post a donation if you'd like to. So if you'd like to donate to the Buffalo Astronomical Association, that's what you can do. You certainly are more than welcome to donate to Penn-Dixie as well, or the Buffalo Museum of Science. Certainly you can join them on their web pages as well. And again, we thank you very, very much for all of that fantastic information, Dan. And again, if anybody has any questions, if you have any comments, certainly. Now, Mary says, thank you, Dan. And Rosemary says, this is a great presentation and very, very informative, Dan. So very, very cool. Again, everyone out there, thank you so much for joining us this evening as we continue looking up our live Facebook and YouTube presentation. And it's a virtual star party. Yes, you heard us right, a virtual star party. But this evening, Western New York is, well, snowed in. Yes, you heard me. We got some snow and some clouds, which happens. And in North Carolina, the seeing wasn't good enough to be able to show us some live video, but we are able to send you a great presentation. So again, thank you so much for supporting us and joining us this evening as we go. Now, the next thing that we have, I really want you to pay attention to, because this tells us what we're going to do and what we're going to see and what's up in the night sky. And we have an outstanding presentation for you. And this outstanding presentation is brought to you by none other than the one, the only, Tim Collins. Yes, Tim Collins from the Buffalo Museum of Science, from the Whitworth-Ferguson Planetarium. Tim, why don't you just fill us in on what's going to be up in the night sky? Over to you, Tim.
Thank you, Dennis. Many of you may wonder why I'm masked. This is not a fake background behind me. What you are seeing is the brand new Whitworth-Ferguson Planetarium. And I'm going to pan up a little bit here so you can just see how big that dome really is. And it is fully illuminated by a set of LED lights that actually illuminate outside the building, which is completely covered with glass. So gone are the days where people will say, I didn't know where you were located. So now tonight it is actually glowing blue. It had Buffalo State colors on it for a long time, but they've changed the color scheme to blue and purple now. And behind me right now is a sold out program going on. And what they're talking about is exactly what I'm going to be talking about with you. What is up? So the program going on under the dome is pretty much similar to what I'm going to do here. So without any further ado, I'm going to start sharing my screen here. Whoop. Let me get that straightened out here. Share the screen. And we're going to bring you to Stellarium here. Now, Stellarium, I don't know if somebody had said it, but Stellarium is a free application that you can also download to your PC or to your Mac, and it will give you a virtual planetarium on your desktop. So it is an incredible program. We love to use it, and it actually teaches you more about the night sky than you could probably imagine it could. So we are set right now for today back at 5:15. And the reason I bring that up is that it's just before sunset. And what I want to show you here is I want you to get a look at what's going on in the sky. Over here around sunset, we have 3 planets tonight plus the moon. So Venus was up along with Saturn, Jupiter, and the moon here. Now, as Emily Ann had indicated earlier, the moon is headed toward full moon, and when it gets there on Friday, we will have that lunar eclipse. So, good time to view the moon in a waxing phase right now. And what's good about that is that that is actually one of the best times to view the moon, because you never want to see it when it's at its full brightness at full moon. It kind of hurts your eyes. But you get to see some amazing features, and we'll highlight that, I'm sure, in some other programs going forward. But just to bring up that these planets are out here for you to see. And it's very nice to have them nearby just after sunset. And as I was driving in this evening, I did take a look toward the southwest, and I did see all 4 of these just like this before Dennis sent us all that snow. So we're going to go ahead and say, Dennis, it should stay down near you in the South Towns. Don't bring it up here, but we got it anyway. So I don't know what it's like up in my area near Amherst, Williamsville. Maybe some of our viewers up in the northern tier can chime in and let us know if they can see anything out there. And that's the kind of the fickleness of weather around Western New York. Some places will be cloudy and snowy, and some places will be clear, and they'll be saying, what snow? So get used to that. It's back now. So it's amazing to look at these planets. And of course, there's one thing you need to know about planets. And when you see them, they do not twinkle. Now, you may have learned a song in grammar school about twinkling objects, but I can guarantee you it was not about twinkling planets, because that is something that does not happen. Planets don't twinkle because they reflect sunlight. And this particular arrangement here makes a good demonstration for me, because with the moon, I can also ask you if you have ever seen the moon twinkle before. And of course, the answer is no, because the moon is also reflected sunlight, just like these other 3 bodies here. So the other thing we can see are stars in the sky, and here's one down here as it gets a little bit darker. And stars do twinkle because they are energy. They emit their own light, and that energy must get through our atmosphere. And as it does so, it bounces around and it causes that twinkling effect. So that's how you can tell the difference between a planet and a star. Now, if you're ever to go to space, I know it's slowly becoming more popular, and everybody knows that from Mr. William Shatner going up in space lately. All bets are off. Nothing twinkles up there. So you're on your own. So you have to know where things are when you're up there. So that is a very early look. Now there's something even more amazing. We're going to advance by some hours here. And I want to show you something else that also happens to be up. And I think to do that, I have to slide up a little bit higher here. And I think I went by one of them already. It's not really showing for me, but I can tell you what else is up here, and I'm going to see if I can make it appear. I'm going to see if I can force it here through our great program. One is the planet Uranus, and the other one, which is somewhere near the area between the moon and Uranus, and I don't know why it's not showing up, is also Neptune. Now, these 2 planets at the back of our solar system, you cannot, let me repeat that, you cannot see them with the unaided eye. You must have a telescope to see them. So if you have a decent telescope, one that will track for you, or if you even want to try to do it on your own, you can look for these. If you have something around the 8-inch range of telescope, then you can pick up some of the disk shape. So it's a very, very planet-filled sky lately. The only 2 that you do not see here are Mercury and Mars. So the only 2 we haven't mentioned. And that is because they are over by the other side of the sun. So if we continue, and yes, those are all star names. We continue toward the sunrise side. You'll begin to see here, whoop, don't go too far. As we head into sunrise, Mars is just beginning to rise over the horizon at 6:20 in the morning. Mercury, however, is just a little bit too close to the sun still to see. It's down here right by Mars, but it's so low. I'm going to go by minute here and roll this back slower. You can see that it's just a little bit too low, even though the sun might be below the horizon. The glow from daylight, when I turn it back on here, so I remove the daylight effect, and you can see what happens when the sun rises. So Mars and Mercury are not quite there yet, but we're getting there. It's pretty close. So that's a planet look tonight. Now, there's some other things going on that they've already mentioned. The comet that you can see early in the morning, Dan's taking care of that. Emily Ann is taking care of the lunar eclipse on Friday. And again, just to reiterate, that is Thursday night into Friday. And one thing I told people when I was at the museum today, and they were pretty astounded by this, is if you happen to have a south-southwest facing window at 4 a.m., you can see the lunar eclipse as long as it's not cloudy, and as long as you don't have trees that may still have leaves on them. So you don't even have to leave your house to look out a window and just glance up at the moon and see that amazing reddish color. So that is a fantastic opportunity. Now I'm going to go backwards, and normally we don't go backwards in time because this is not Back to the Future, and we do not have a DeLorean in our midst, but we're going to head back a little bit here toward just about a few moments from now. And I'm going to pan the sky up just a little bit. And I want to bring your attention to three particular stars that aren't all labeled for me, but Deneb here, Vega here, and we have Altair over, it is labeled, Altair over here. This makes up the summer triangle. And yes, the summer triangle is still visible at this time, almost winter. And it is a fantastic area of the sky. And if you notice running through the triangle, you see a fuzzy patch here of light. And that is where the Milky Way goes. So you can see the Milky Way and trace it out. So if you are in a darkened area, you will get to see the Milky Way. And around these three stars, is the summer triangle is not actually a constellation. It is a special pattern called an asterism. And an asterism has a couple of different definitions. This one pertains to borrowing other stars from other constellations to make up your own pattern. And that's exactly what we do with the summer triangle. Now, if I were to turn on some constellation outlines here, you will see that those patterns belong to Aquila the Eagle for Altair, Lyra the Harp with Vega, and Cygnus the Swan for Deneb. So each of those stars is the brightest star in its respective constellation. And there's some other constellations too here. One of the ones we like to talk about here is Vulpecula. Vulpecula is a fox. And here's the thing about constellations. Do you see a fox there? You probably don't. And that's okay. But the constellation outlines, they're not exact patterns and they're not dot to dots. They are just guidelines and skeletons for you to use your imagination in order to put the object around there. Now, sometimes in the case of Cygnus, you can see the swan's wings here, and you can imagine the swan's long, graceful body from his tail, which is what Deneb means in Arabic, up to his head. And when you look at his head here, that is another star, and that star is called Albireo. And if we look at it, and we've done this in the past through a telescope, you don't just see one star, but you see two. And you can see this even in a smaller 3 or 4 inch telescope. You can get the resolution to definitely see a golden star, which is the one you're seeing here, and a companion, kind of a robin egg blue star. So some things that you just have to see once in your life, Albireo is one of them. It's a little bit, it's almost halfway between Altair and Vega, but it is the head of Cygnus the Swan. So it's an easy target for a telescope and gives you good practice in using that telescope. And of course, there are still some other fun constellations of the fall still with us. One of them, of course, is Pegasus, the winged horse, and it's usually marked by the Great Square, although this star does not count as part of Pegasus because this star belongs to another constellation called Andromeda. And Andromeda is the princess, and she is this strand here. And there's another strand here that's not outlined that's going up through here. And if you look at this little mark here, you can almost make a letter A, and the A stands for Andromeda. And when you follow the A to this point, you get a special object here, and it is called, I didn't mean to turn all that on. It is called the Andromeda Galaxy. So you can actually see another galaxy. It is our galactic next door neighbor. It is the closest galaxy to us. And it too is a great target for a telescope this time of year. So those are just a few of the things. And then the last thing I want to bring up is over here in the east. Look who's coming back to our view. You're beginning now to see the constellation of Orion the Hunter returning to the sky every winter, as dependable as he is. So that is something to look forward to. And also the three belt stars at this time at about 8:30 at night are just cresting the horizon, which means if we follow it just a little longer, by 10:30, Orion has cleared most of the trees here, and definitely by midnight, Orion is now clearly visible in our night sky. And one other great telescope target, the Orion Nebula down here below the middle star in his belt, and hanging down as the sword of Orion, or at least the sheath for the sword. And that's where you will find that nebula. So I think that is about all I want to. I could go on all night long with all this. I don't want to overwhelm anybody. This is a lot of fun to do. And you can just keep on looking at everything in the sky, and all you have to wonder is, what is that? And if you don't know, you can come back and ask any one of us at any one of these institutions. We will be happy to share it. I think Dennis has reiterated that tonight many times. We love doing this. And so we have no problem if you want to drop a line on the BAA site or on any of the affiliate sites, let us know. We're there for you. So that is your looking up for November. So I'm going to go back to Dennis.
Wow. Just wow. Outstanding. Tim Collins, what a tremendous presentation. Yes, even though Britta McCarthy says she's an astronomy newbie, her head hurts, the head hurts a little bit, but that was all great info for me. Yes, we're all about sharing astronomy for anybody who's new, who's anywhere along the line, because there are always things to learn. Like, we don't typically go back in time, but did you know that as an astronomer, you are a time traveler? Yes, a time traveler. You're actually looking back in time. Think about that for a minute as we talk to you about our next event that's going to be coming up on December 11th. Yes, December 11th is going to be our next Looking Up virtual star party. You heard me right. We're going to be doing this again. And yes, we can use your support. We can use your help. But December 11th, the next Looking Up event, yes, 7 p.m. We'll be here for you again coming up in December. Now, as we move forward in this presentation, as we take a look at all things up in the sky, yes, we're looking up, and this is a live virtual event brought to you by the Buffalo Astronomical Association, the Penn-Dixie Fossil Park and Nature Reserve, the Buffalo Museum of Science, the Williamsville Space Lab Planetarium, and something new, something exciting. Okay, it's been there for a while, but this is really exciting. Back to Tim Collins at the Whitworth-Ferguson Planetarium. Tim, why don't you tell us a little bit more about the Whitworth-Ferguson Planetarium before you give us a presentation?
I would love to do that. Thank you, Dennis. So again, just to restate that I am live here from the Whitworth-Ferguson Planetarium. We reopened on October 8th to the public, and we are doing a myriad of shows right now. Our first program in the evening is a movie which turns our dome into a giant movie screen. and we allow people to go with the characters on a trip to Mars in a program called Mars 1001, which details the 1001 days these astronauts spend in space going to Mars and back. And we also will, following that, give you a quick tour of history and topography of Mars and some of the rovers that are there and what's going on with Mars research. Our next program, which is going on behind me right now in this very dome, let me point the right way, is our program on the night sky, which is similar to the one I just gave you a short moment ago. And there are about 45 people in there right now, and they should be coming out in about 20 minutes. Just as enthralled as anybody would be going inside a planetarium where they basically see a theater of stars. And I am so lucky to be able to be here and at this Museum of Science and do some part-time work at Williamsville North as well. It has been a very rewarding time to do that. So how do you get here? What do you see? That's what I'm going to show you right now. And I'll tell you about a couple other programs when I get back. So I'm going to bring that up and let you view this. And I will talk to you again in just a moment. Okay, so I am going to let one of my colleagues repeat that on the chat window since I can't do it at this point, but it's oh, you got it, you got planetarium at buffalostate.edu. And that brings me to the other types of presentations that we are doing at the planetarium. And you saw at the end there that light show that we are doing, and those are called laser shows. You may be familiar with them. They were very popular in the 70s, 80s, and 90s. We do have a full system along with a beam effect system, which you were witnessing in that program. So we are running two shows right now. At 9 p.m. tonight is Laser Queen, which is an amazing program unto itself. And at 10 p.m. is Pink Floyd's The Wall. So you can come and check those out too. You will not be disappointed in any way. I can say that personally and with a little bit of bias. But in addition, in a couple of weeks, we're going to switch the laser shows over to our holiday program, aptly titled Laser Holidays. And as you can imagine, it is a laser program set to holiday music. And it is just a great time for everybody. So it is a very inclusive program, so it should be great for all. So please come and check that out sometime. Along with the astronomical programs as we change things throughout the seasons. I can tell you this, after we closed the old planetarium, and people are going to be shocked when I hear this, but it was on January 4th, 2013. That was almost 9 years ago, and we have been waiting that long for the building you see behind me. And finally, we have this. In the meantime, we had been in an inflatable planetarium, which was fun, but we kind of overstayed our welcome. We were waiting for this so badly, but we are so glad we waited. And we now have a fully state-of-the-art planetarium. Our old dome was 24 feet across. This one is 35. So it is a much bigger facility inside. And we have a 4K system to bring you those full dome movies and those laser shows. So I get choked up just talking about it because it's so amazing. And I was just in there a little while ago to help set up this program, and I even have people coming in now for Laser Queen. I can hear them coming in. So you will see people walking around behind me shortly as they begin to gather. There's still room if you can get here by 9. You can go online to the planetarium website, or you can go to Eventbrite and look up the planetarium, and you can still buy tickets if you want to. And if you do, tell me you saw it on Facebook, and we'll mention you when you get here. We'll put you on the air maybe. That'll be your incentive. So with that, that's what's going on here. We look forward to having a number of more experiences with everybody here as the Whitworth-Ferguson Planetarium re-enters the public realm. So we are glad to be back, and thank you for having us here. Dennis, back to you.
Why, thank you very much, Tim. That was, again, outstanding. And yes, folks, we are doing this live. And yes, it is 8:37 p.m. So if you're close enough to Buffalo State College, don't speed, but you can get there for Laser Queen, an outstanding show. Yes, you heard us right. You could still get there and maybe even appear right on this presentation. We'll have to see about that, but we can try. We'll do our best to do that for you. And now we don't have a lot of questions out there, but Rosemary said she is so very glad that the new planetarium is open at Buffalo State College. Her family and I visited the previous planetarium many, many years ago, and we are so glad that this new planetarium is up and running for everybody. Yes, we really do appreciate you joining us here live for our Looking Up event. Our next event coming up December 11th, or excuse me, in December, most certainly is outstanding and going to be a fabulous presentation. Of course, I'm not going to be joining you in December because I will be out of town, but I know that Tim Collins will be back, and most likely Emily Ann and Dan and our producer, Gene. Again, we thank you for joining us. If you do have any questions, please feel free to type them into the chat, and we'll do our best to get them on air for you and share them with the audience. Again, you can also join us all on our websites at the Buffalo Astronomical Association, at the Penn-Dixie Fossil Park and Nature Preserve, at the Buffalo Museum of Science, at the Williamsville Space Lab Planetarium, and the Whitworth-Ferguson Planetarium. And yes, I did post a link to the planetarium at buffstate.edu, and it is there for you to click on if you'd like to, and certainly check that out. It is outstanding. And of course, we do this to share our love of astronomy with you, and any donations would be helpful. You can certainly donate, and I'll post that again link in the Facebook Live for you in case you didn't see it. We certainly can use your help to meet our goals and to help spread astronomy to everybody through our virtual Looking Up events. This is what we can do. Now, we certainly are looking at doing some incentives, including some observatory maintenance and bringing Wilson Star Search back to live events. We had been able to start doing some live events at the end of the season at the observatory. We do have our high-speed internet, so hopefully we'll be able to share some live views when we get some clear skies and doing these events. So it really would be outstanding for you to help us out and spread the word of astronomy to everybody. Well, we've had a tremendous evening. We've had presentations by Emily Ann. We've had presentations by Dan Marcus. We've had presentations by Tim Collins. And now, without further ado, I have to introduce to you the most important person in the Buffalo Astronomical Association. Yes, our very own president, Mike Humphrey. And Mike, Thank you for joining us this evening, taking time out of your busy schedule as a president. I know that you are taxed to the end, so it is wonderful to have you join us here this evening. And you're going to fill us in on what's coming up next month. And Mike Humphrey, over to you.
Oh, thank you so much, Dennis. I really appreciate it. And yes, we are blaming you for the snow because at the last meeting, you kind of mentioned that. We kind of laughed and we got the snow. So everybody out there, please blame Dennis for the snow. And thank you very much. I'm glad everybody was able to join us. We like doing this. And again, this is all volunteer. It's all because we like doing this. We'd like you, if you're interested, to join us. Not only on the shows, but actually become a member of the BAA and join us because there's so much stuff going up in the sky, but there's a lot of stuff going on down on the ground too. And that's kind of what I wanted to talk about. There's a couple projects that are coming up, and now that things are loosening up a little bit, you'll be seeing more of these things. As an example, one of our partners is the Buffalo Library. And you may or may not be aware that the library has been loaning out telescopes for quite some time. So what we're going to be doing, some of these people are borrowing the telescopes and they're saying, I don't know what to do with these. So we're going to be offering some classes at the library. And this would be a class you can come in. We'll show you how to use the telescopes, what you should be looking at, just showing you how to have some fun. Because all of this, and everybody's been saying the same thing, we're all doing this just to have some fun. Seeing us live is really, really the best way to see us because this is fun, but we have a couple of events now. I'll tell everybody exploring more. We're going to be there. We're going to be live. We're going to have equipment. You'll get a chance to come in, sit down and talk to us, ask questions because we love to answer questions. One of the things that's really fun about this because there's so much stuff going on and everybody's trying to figure out, you hear about the second moon, what's going on with the Webb telescope. Ask us. Hopefully we will be able to give you some answers. Another thing that's happening, with the high-speed internet out there at the observatory, one of the plans is to start doing classes from the observatory. So we'll be able to do things that like this or working with some other things. So you'll be able to see some more stuff, be able to answer questions, see what's actually going on there. Occultations are fun. Seeing what's going on at the eclipse is fun, but also seeing the ISS. And when you know what it is, and then you see something streaking across the sky, that's really, really kind of fun to be able to tell all your friends, look up there, this is what it is. This is what I'm seeing, and to be able to know what's going on behind that. And another thing, I just wanted to bring this up too. Dennis mentioned that in December, we're going to have on the 11th is going to be our next looking up. Why are we doing on the 11th? Well, on the 10th, we have an event going on. This is going to be at the Museum of Science. It's a science night. And again, some of us will be there and we'll be there live. Dennis is going to be out of town, but I'll be in town while he's out there having a great time. So you'll be able to see me and a couple other people will be out there. And again, we'll be there answering questions. Bring them. We'll be able to hopefully answer those for you and talk to you about what's going on. Another thing I wanted to bring up is we have working now with NASA and they have a community association and they invited us to be part of that community association. What that does is it gives us access to a lot of information, a lot of things. So if you're interested in something, hopefully we'll have the resources to be able to do that. And this is a good resource for everybody here. So if you want to ask questions, you want to learn about some things, go to our website, which is easy to find. It's Buffalo Astronomy. If you're in Buffalo and you want to know about Buffalo Astronomy, type that in your browser, you'll be at our site. You'll be able to see where we're going, the things that we're doing, a lot of events going on, and hopefully be able to join us at some time. Right now, this is a great forum, but we want to see everybody live too. So I'm only going to speak for a couple of minutes. I'm going to throw this right back to Dennis because I know he's not ready for me yet. So I am. Thank you very much, everybody, for able to come out. Hopefully, we'll join up, become a member, and join some of the things that we're doing. It's a lot of fun.
Outstanding. Again, Mike Humphrey, thank you for taking so much time out of your busy schedule for sharing us. I'd certainly like to poke in there and say hi to Tim Collins again, because Tim, it looks like you have some people who joined you. Did they join you from Facebook Live? I'm not sure if Tim can hear me, but he might be able to hear me. I'm not sure. Oh, I think he's plugging in his headset now. Tim Collins, are you there, sir? Yes, you're there. There are some people here. behind you. They're waving to us right on Facebook Live. Yes. Oh, I'm not actually hearing Tim, but we are seeing those people live. They are at the Whitworth Ferguson Planetarium. Yes, going in for the live Laser Queen show. Laser Queen show will be happening. I can't really hear Tim. I'm not sure what's up with the audio there, Tim, but certainly outstanding to see those folks up there. And so, well, we really do appreciate you joining us this evening. Oh, I'm sort of hearing Tim. Not hearing exactly, but that's okay.
Is it better now?
And now we can hear you, Tim. Yes, now we can hear you.
Okay, good. Yeah, the lights are starting to go off here to add to the dramatic effect. Okay, the audio problem's corrected. One more time, say hi. Okay, now
So
there
we have
they
a
are.
big group there, huh, Tim?
Yeah, we have half the group here and more coming in as we speak. So I'm watching the entry here and they're coming in. I tried to convince them that they were seeing Laser Beethoven, but they didn't buy it. They're really here to see Queen tonight. So, and
Most
they're in for a
definitely.
treat.
So,
'Cause,
Tim,
Yes.
before I go over to Emily Ann, who's going to show us a little bit about her presentation and her favorite slide, how about you share with us the little bit that you have about the Whitworth Ferguson Planetarium? You put together a wonderful, wonderful little presentation there about what's happening there. Would you mind sharing that with us again and telling us a little bit about what's happening there?
Oh, sure. Just give me 1 second here to call it back up.
Sure, no
And
problem.
I will do that.
I called Tim into short notice to share his advertisement. Well, okay, not really an advertisement, but it is. We certainly like sharing this with everybody and sharing astronomy with everybody, and this is one of the ways we get to do it. So go ahead, Tim.
Okay, here it comes. Thank you.
Another outstanding presentation. Yes, that live link is there for you in the live chat on Facebook Live. Visit the planetarium, and it looks like Tim Collins has a guest for us live
Thank you.
here from the Whitworth Planetarium. So go ahead, Tim.
Facebook Live, visit the planetarium, and it looks like Tim Collins has a guest for us live. Thank you. Go ahead.
Okay, 1 second. I still have some audio playing here, but I do have a guest with me, somebody who's here to see something. So we're going to ask him a couple of questions. Sir, what is your first name? It's a delay.
My first name is Ed.
Hi, Ed. It's great that you could come out here to the Ferguson Planetarium tonight. This is, of course, our second month now, and you are here tonight to see Laser Queen. And what brought you to Laser Queen tonight?
Well, my family actually brought me here
for my birthday as a surprise. So I have no idea what I'm here to see, actually. But I heard you say Queen. So yeah, I guess it's about Queen. And
Oh
laser.
no!
Yeah,
I
but
hope
it's
I
all-
did not spoil the surprise.
No,
Oh
it's
no,
good.
everybody! I think I spoiled
It
this
was-
birthday surprise. Well, happy birthday,
was a-
Ed! This is
Well, we looks like we lost a little bit of that audio there. So I don't know. Tim will hear me in about few seconds as he comes out again. He may not hear it. So Ed, happy birthday to you. Very much so. We really hope that you enjoy the presentation there out at the Whitworth Ferguson Planetarium. Tim, we lost the audio again. So I'm not sure if you hear me, but we lost the audio again. That can happen as we move those headsets around, but that's okay. So, well, that happens. We lost the mic and that happens, but certainly happy birthday to Ed and anybody else out there celebrating their birthday this evening. And again, thank you for joining us here live on Facebook as we're kind of coming to the end of our presentation. Now, we've had some outstanding presentations this evening. We opened this evening with Emily Ann, who had a really tremendous presentation about November 19th and the upcoming lunar eclipse. Now, she had a certainly most favorite look at a slide that she had in that presentation I thought was outstanding, and I learned a lot of new stuff. So maybe Emily Ann can kind of touch basis and maybe hit some of those highlights or a brief recap of your presentation again for us, because it was so outstanding. Emily Ann, can you share that with us?
Of course I can, Dennis. Thank you very much. Let me pull that back up here. Yeah, I think I don't know. I definitely like found a lot about eclipses that I didn't know before a little bit. Like I said, I've seen eclipses, I've observed some of them. Not a solar eclipse yet. We'll see. I'm definitely 2024. I'm gonna, try to go somewhere fun for that. But yeah, I think my favorite really was learning about how Earth's atmosphere affects, the color of a total eclipse like that. I did not know. I think I had always kind of assumed before. But I never really knew, and this is kind of one of my favorite pieces that I learned a lot, definitely when I was putting this together, is that Dan John scale, and that, anyone, looking at an eclipse, anyone watching, you can kind of just go out and think of it in terms of numbers and think about the way that Earth's atmosphere is affecting, the color of the moon that you're seeing. I just never considered that before. I thought that was really nifty, and the way the light, comes through. Now I'm sort of, I don't know, I just thought that was very, very neat. Where you are and how that affects. And I also thought it was cool, the umbra, the concept of you hear those terms, I hear them, we talk about them all the time in the club. And I think eclipses are interesting to me, but I'd never thought about the deep shadow and how it, I don't know, I always enjoy trying to find images when I do the presentations, trying to find, of course, images without copyright that can be shown to the public. But people on Wikipedia make these wonderful graphics. You really learn so much, just kind of putting these in and seeing the way that, that even the difference in the depths of the shadow, just, and it's amazing thinking about the fact that it all just happens to line up like this. I think I don't have a specific number, but I know that, the orbits of Earth and the moon are changing. So we're over millions and millions of years, the moon and the Earth are gonna kind of come out of alignment. So in, a couple million years or so, you're not gonna get solar and lunar eclipses the same way that we see them now. So that's kind of something interesting to think about, is that, just orbits change over millennia. So it's gonna change so that the moon is gonna, I don't remember exactly, but I'm pretty sure it's that eventually the moon will not be able to fully cover the sun. So, as time passes. So that's kind of amazing, thinking that we're here for this specific time and we get these wonderful, solar and lunar eclipses. But I don't know, just it was a definitely fun presentation. And just a sneak peek, my presentation next month is going to be on winter observing. So if you are interested in practical winter observing and keeping warm, I might have some tips. Hot hands, that's my tip, but I'll talk about that more. But yeah, I think back to you, Dennis. And if anyone has any questions about the, lunar eclipses, maybe even solar, I could probably answer them. So back to you.
Certainly most outstanding. Thank you so much, Emily Ann. And folks, with that, we certainly want to thank you for joining us this evening. Again, the folks here at the Buffalo Astronomical Association, the Penn-Dixie Fossil Park and Nature Reserve, the Buffalo Museum of Science, the Williamsville Space Lab Planetarium, and the Whitworth-Ferguson Planetarium. Certainly thank you for joining us this evening as we spread our love for astronomy. Again, a great thanks goes out to Emily Ann for an outstanding presentation, to Dan Marcus telling us about the brightest comet of 2021 in the morning. Yes, you heard it, the brightest comet of 2021, Comet Leonard. Dan Marcus certainly shared some outstanding information and some wonderful images of the comet, as well as some previous comet images. Tim Collins's What's Up presentation and the Whitworth-Ferguson Planetarium conversations, as well as their presentation, was outstanding. So next month, come back and join us in December as we keep looking up.